when we go to solve two equations simultaneously, what we try to do is find a value for x and y in this case, or whatever letters we're talking about, that work for both equations. But when we have to do this graphically, it's even easier than algebraically, because you'll see in this question here, we're asked to solve these two equations simultaneously. And what we have to do is, the first thing is that we draw the two equations. And in this case, they've been drawn for us. Here's the first one, 3y plus 2x is 12. And here's the second one, y equals x minus 1. And there's one point that sort of jumps out at you in the graph, and that's the point where they cross, this point here. And at that point is on both the lines. It works for both the equations. And so all we have to do to solve them simultaneously is say, okay, what's the x coordinate? That's 3. What's the y coordinate? That's 2. And so we solve that. The coordinate is the coordinate 3, 2. And so if we want to solve the equations, the x value of that coordinate is 3 and the y value is 2. And we've solved those equations simultaneously. In this next problem, we're asked to solve two simultaneous equations, and one of them is already drawn for us. The line y plus 2x equals 5 is drawn here for us. But we want to draw also the line y equals 2x minus 1. And so, as we've seen before in other videos, to do that we need to make a table. So my x values and my y values. We're just going to make it into a little table. And I'm going to pick 3 points, 3 values of x. Let's try maybe minus 1, 0, and let's try 2. And let's find out what values of y go with those. So, when x is minus 1, 2x is minus 2, and when I subtract 1, that's negative 3. So when x is minus 1, y is minus 3. When x is 0, 2x is 0, and I just take away 1. So when x is 0, y is minus 1. And when x is 2, 2x is 4, take away 1 is 3. And so we're just going to plot those points and draw that line. So there's the 3 points plotted, and now we just join them up with a straight line. And there you go, straight line drawn. The only other thing I want to put on that graph is the equations of those lines. So let's write in this one, y equals 2x minus 1. And this one that was already drawn for us is the line y plus 2x equals 5. But now that they're drawn, solving them simultaneously is straightforward. We find where they cross. That's the intersection there. And if I go down, I see that x is 1.5 and the y value is 2. So the value, the coordinate, sorry, of where they cross is 1.5, 2. And so x, the x value of where they cross is 1.5, or I'm going to say 3 over 2, and the y value of where they cross is 2. And so we've solved those equations simultaneously just by drawing the graphs. You can always check your answers, just like in normal simultaneous equations by algebra. What we can do is check our answers 3 over 2 and 2. Do they work in our equations? Well, 2 times 1.5 is 3. Take away 1 is 2. So when I put 3 over 2 in for x, I get 2 for y. So it works in this equation. And also in the other equation, 2 plus 2 times 1.5, so 2 plus 3 equals 5. Yes, it works in both equations, and I can be fairly confident that I've got it correct. Here's a couple of questions for you to have a go at. One of them's already drawn out for you. The other, you'll have to draw the two graphs and solve the simultaneous equations. Just pause the video and restart it to find out the answers.